have to reduce demand now. Now, it is really important, the supply side. I'm not saying it's not important. It is essential. But if we do not do something about demand, we will not be able to hold to 2, probably even 3 degrees C. Now, that's a global analysis. And the argument would be, well, we have signed up repeatedly on the basis of equity. And when we say that, we normally mean the poorer parts of the world will be able to peak their emissions later than we will be able to in the West. And that seems quite a fair thing that probably no one would really argue, I think, against the idea of poorer parts of the world having a bit more time and space before they move off fossil fuels, because that links to their welfare, to their improvements, that use of energy. Now, let's imagine that the poor parts of the world, the non-OECD countries, I usually use the language of non-Annex 1 countries for those people who are familiar with that sort of IPCC language. Let's imagine that those parts of the world, including India and China, could peak their emissions by 2025. That is hugely challenging. I think it's just about doable, particularly if we showed some examples in the West. But I think it's just about possible. As the emissions are going up significantly, they could peak by 2025 before coming down. And if we then started to get a reduction by, say, 2028, 2029, 2030 of 6 to 8% per annum, which again is a massive reduction rate, that is a big challenge for poor parts of the world. So I'm not letting them get away with anything here. That's saying if they did all of that, you can work out what carbon budget they would use up over the century. And then you know what the total carbon budget is for 2 degrees centigrade, and you can say what's left for us, the wealthy parts of the world. That seems quite a fair way of looking at this. And if you do it like that, what's that mean for us? That means we'd have to have, and I'm redoing this now, and I think it's going to be well above 10%, because this is based on a paper in 2011, which was using data from 2009 to 10. So I think this number is probably going to be nearer the 13 to 15% mark now. But about a 10% per annum reduction rate in emissions year on year, starting preferably yesterday. That's a 40% reduction in our total emissions by 2018. Just think of our own lives. Could we reduce our emissions by 40% by 2018? I'm sure we could. I'm sure we'll choose not to, but I'm sure we could do that. But a 70% reduction by 2024, 2025, and basically we'd have to be pretty much zero carbon emissions, not just from electricity, from everything, by 2030 or 2035, that sort of time frame. That's just the simple, blunt maths that comes out of the carbon budgets and very demanding reduction rates from poor parts of the world. These are radical emission reduction rates that you cannot build your way out of. You have to do it with how we consume our energy in the short term. Now, if that looks too difficult, well, what about 4 degrees C? Because that's what you hear all the time. That's too difficult. So what about 4 degrees C? Because actually the 2 degrees C we're heading towards is probably nearer 3 now anyway. So depending on your probabilities. So let's think about 4 degrees C. Well, what it gives you is a larger carbon budget. And we all like that because it means I can attend more fancy international conferences. We can carry on going on rock climbing holidays in my case. We can all carry on doing and living the lives that we like. So we quite like a larger carbon budget. Lower rates of mitigation. But what are the impacts? This is not my area, so I'm taking some work here from the Hadley Centre in the UK, who did some analysis with the Foreign and Commonwealth Office. But you're all probably familiar with these sorts of things, and there's a range of these impacts that are out there. A 4 degrees C global average means you're going to have much larger averages on land, because most of the planet is covered in oceans, and they take longer to warm up. But think during the heat waves what that might play out to mean. So during times when we're already under stress in our societies, think of the European heat wave. I don't know whether it got to Iceland or not. In 2003, well, it was quite warm in the rest of Europe. Too warm. It's probably much nicer in Iceland. There were 20 to 30,000 people died across Europe during that period. Now add 8 degrees on top of that heat wave, and it could be a longer heat wave. And you start to think that our infrastructures start to break down. The cables that we use to bring power to our homes, to our fridges, to our water pumps, those cables are underground, and they're cooled by soil moisture. As the soil moisture evaporates during a prolonged heat wave, those cables cannot carry as much power to our fridges and our water pumps. So our fridges and water pumps can no longer work. Some of them will be now starting to break down. So the food in our fridges will be perishing at the same time that our neighbour's food is perishing. So you live in London, 8 million people, 3 days of food in the whole city, and it's got a heat wave, and the food is anyway perishing in the fridges. So you think you're going to bring the food from the ports, but the similar problems might be happening in Europe. And anyway, the tarmac for the roads that we have in the UK can't deal with those temperatures, so it's melting. So you can't bring the food up from the ports. And the train lines that we put in place aren't designed for those temperatures, and they're buckling, so you can't bring the trains up. So you've got 8 million people in London, in an advanced nation, that is starting to struggle with these sorts of temperature changes. So even in industrialized countries, you can imagine this playing out quite negatively, a whole sequence of events not looking particularly positive. In China, look at the buildings they're putting up there in some of Shanghai and Beijing and so forth. They've got no thermal mass. These buildings are not going to be good with higher temperatures, and yet we still see big increases there. And in some parts of the States, could be as high as 10 or 12 degrees temperature rises. These are all a product of a 4 degrees C average temperature. At the same time, big increases in sea level. Many of you here know much more about that than me, but I think people think not uncommonly about 1 metre by the end of the century if you're heading towards these sorts of emission rates, and it would keep going up beyond that. And that has big implications. We've seen 20 centimetres, I think, so far from thermal expansion, but obviously that would keep going up. But I think also very significantly, food crops. This is work, again, from the Hadley Centre, a 40% reduction in the staple crops in some of the lower latitudes. And that's not just due to, in fact, most of that, I believe, is not due to changes in precipitation, but is due actually to the temperatures themselves. So at 2 degrees C, precipitation is a big issue. I think at 4 degrees C, the temperatures start to play a big issue. And at the same time, of course, the population is going up, and we're needing to eat more food. I think it's fair to say, and I'd be no interested if any of you disagree with this here, there's a widespread view that 4 degrees C is incompatible with an organised, I'd like to say civilised, but I'm not sure we ever quite got there, an organised global community. I think we would probably end up, as we normally do, particularly men, we will reach for the Kalashnikov and we'll end up fighting each other for scarce access to resources. And there's plenty of good examples of that's how we respond to difficult situations. I think it's beyond adaptation, 4 degrees C. Okay, you might be fine if you're in Iceland. My family come from the west coast of Scotland on an island, so I'll be going to visit them. But there's so will lots of other people trying to get to these parts of the world. So maybe a few of us can adapt. For many people, we will not be able to adapt to this level of changes. It will be devastating to ecosystems that we survive and rely on, but also ecosystems that I think have not just an instrumental right to be there, but there's something more immutable about them. They're part of our planet, and it is not our role to destroy them in the rates that we're doing now. And certainly as we head towards 4 degrees C, there may well be other tipping points, non-linearities out there that mean that the temperature rise could keep going up to a much higher equilibrium level. So you'll have heard about those, and there's a lot of uncertainty around them. All we know for certain is that the higher the temperature goes, the greater the chance that these tipping points could be important. And I don't know anyone really that doesn't agree with that 4 degrees C temperature rise as a global average should be avoided at all costs. And I quite like that, because for economists who really are obsessed by discount rates, certainly neoclassical economists, means that it doesn't matter what discount rate the economist applies, you have to do something about it. So you cannot make an argument that it's too expensive. We have to avoid this at all costs, because we cannot survive there in any significant numbers, and also I think it is detrimental